Right, what you're going to be seeing here is how we actually fit the Thermomax evacuated tubes. Now, it's a really good concept because as the kit comes, it actually comes in 3 different boxes. So instead of having to try and lift a great big lump up onto the roof, we can actually do it as a one-man fit by taking the boxes up and actually install it as you go onto the roof itself.
Right, now, Steve, someone mentioned there it comes handily in the boxes for you. Now, just
That's
tell us
right.
a little bit about, before you actually get on site, though, before you start getting up to install it, you need to do a few things, don't you?
Of course. First of all, we're working on a roof, so we need to access the roof, and we need to do that safely. So there will be scaffolding here, there will be rails up the side. Obviously, it's not appropriate to have mocked that up here, so take that as read. The system has to be appropriately specified for the property. So there's a whole series of design steps that would be undertaken by the MCS installer before even selling the product to the customer. And as part of that, we need to ensure, for example, that the roof is appropriate to take the panels, to take the weight of the panels, and that the roof is in good enough condition that it's going to last as long as the panels are likely to be there.
So by the time you get on there, it's absolutely impeccable, ready to go, and you can get up there and start working on it.
That's right. And if there was roof work needed, we'd do that first, like we did here. This was in a terrible state yesterday, and we've re-roofed it all for you.
Right, now we've got our safety barriers obviously around us. They're obviously quite high up here. I've got a head for heights, I don't know about you.
Tone it
but
down.
You're going to bring in Nick, who's part of your YTS scheme, obviously as your apprentice, I can see. Nick, if you want to come in and join Steve. So if you guys want to clamber up onto the roof, I'm going to have a bit of a word with Simon here.
Sure.
One of the key things, of course, is to follow the manual, the instruction manual get, because there's clearly an issue about insurance, potentially.
Yeah, that's right. Obviously, when any manufacturer, or most manufacturers will mention that if everything's installed to the manufacturer's instructions, then you should be on board with it, you should be okay. We take into account already MIS documentation. When we do the manual, it all comes from the sizing all the way through to design and installation. Now, you touched on a good point earlier on about the sizing. Now, a oversized solar thermal system is actually very inefficient. So sizing it correctly is probably one of the most important parts
Size
of it.
matters. This is where you heard it first. Okay, now, Steve, based on the fact that size matters, tell us what you're going to be doing here now.
Okay, we've exposed some of the structure of the roof here for you. Basically, these tiles, nice and easily to slide up. And I waited until we had the camera back to show you this bit, because it's interesting. As I mentioned when we did the PV installation, for those of you who were here, we're fixing directly to the rafter. And these in modern houses are pretty narrow. And the bolts are pretty substantial. So it's very, very important that we pre-drill the holes in the rafter, otherwise we risk splitting it and causing structural weakness.
So the close-up work you can see on the screen, clearly, for anyone who's not spotted that yet. Just in case. Are there any particular special tools that you need with all of this?
All pretty standard stuff. That's the 13mm impact driver. We have on the Kingspan system, everything's 13mm.
Yeah.
On others, it's Allen keys and star drivers and things like that. Things that normal tradesmen easily accessible.
What about planning permission? Do you require planning permission this?
Right, as I said earlier on, it comes under permitted development.
Right.
So obviously, depends on how the surface area, how far you come across the roof. Areas of natural beauty, conservation areas, again, obviously come under different rules and regulations.
Right.
So in reality, permitted development, that covers us most of the time.
Okay, lovely. So where are we now? What's going on?
Okay, now, because for expediency, we'd pre-assembled this a little bit. These strips here, these brackets in this particular system, come as a straight piece of metal, and we've bent them to suit the structure and thickness of this roof. Now that we've got the rails on, one last thing. Nick, pass us the rubbers.
Yeah, you've always got to be careful, you've always got to protect it. So always put the rubber on the bottom of the...
Okay.
This is a specific feature of the Kingspan system. And what we're going to do now is fit the manifold. So Nick's going to pass that up to me. And the manifold is this structure that fits at the top of these rails, and that's what we then will connect the And
that's an occupational hazard. Obviously, we've done that for the purposes of the demonstration. But you would carry spare tiles or slates, wouldn't you?
We do
which would fit
indeed.
in with the
And
roof, so
in a moment, we'll send Nick to the van for a spare. Have you got the 13mm spanner?
It's brilliant the way he does that every time on cue, isn't it?
It is,
it's fantastic. I think he won't get the job, though, frankly. Part of the old YTS scheme. But these really are very simple to fit, aren't they?
Thanks.
Steve?
Yes, and the advantage, as has been suggested there, of this particular system of tubes in general, is that it can be easy to get onto the roof. This is what's called a heat pipe system, which means that the tubes that we're going to fit in a minute are not hydraulically connected to the main system. So we can fit this manifold, we can then fit the tubes independently of that, and we can, if we want, fill this system in the meantime. So if it was on a new build property and they wanted to do the filling and flushing first, that can be done. I'm just going to adjust this and move it across a little.
Simon, I'm right in saying that you have to have a sensor built into this.
Yeah, that's right. We have to have a temperature sensor on the collector itself.
Why? What's the purpose?
Well, the reason...
Would it work without it, actually?
No, not really, because obviously the pump will only run when there's a differential temperature from the coil of the cylinder
so
to the actual collector itself. Yeah, so we actually work on a T-on T-off system. So once we've got 8-degree difference up on the roof than we have in the cylinder, through the sensor will then send a signal to the controller and then kick the pump in. And then when we've got a 4-degree difference below, the pump will then stop pumping and then allow to heat up.
Right.
Now, there is one special thing that we do have with these tubes is we have what we call a temperature limiter into the top of the tube itself. Now, that allows it to get to 95 degrees in the tube itself. So, in reality, we try not to stagnate the system, because obviously as you stagnate the system, it's inefficient. So we try and make sure that we can pump the fluid around the system at a temperature that we can control and then transfer it.
How many tubes do you typically need for a house?
Right, again, it comes back to sizing, because we've got an easy way of doing it. So we can say 1 tube equals 10 litres of hot water, domestic hot water.
Right.
So if you go through Water Eggs or G3 something, it will look at between 40 to 60 litres per person per day is their annual usage, average usage. So we can work out that obviously 5 tubes would do 50 litres of water, so that would probably cover 1 person. But obviously then it comes to the size of the cylinders, because you'll have a primary heat source as well. So we can work it out that way, 50 litres per person per day, 10 litres of hot water per tube, so it makes it a nice rule of thumb, easy sizing.
Right, okay. So, Steve, looks as though we're getting on famously here. So we're now ready, are we, to bring up the tubes? And Nick's obviously going to go back to the van, get a new tile. You're going to send him to bring the tubes up at the same time?
Absolutely, yes. We've just fitted this bottom bracket, and now what we'll do is pass up some tubes to the roof and fit them one at a time.
I guess one of the things you would do, actually, before getting on the roof, is when it would open the packets or the packs down on the ground to make sure you've got everything, because there's nothing worse getting up the top and finding you've got something missing, I guess.
There's very few things worse than finding out something missing. The only thing worse is dropping your last nut from the top of the scaffolding and having to go down and get it.
Brilliant. Okay. Now,
I'll get the tubes
how
down.
robust are these tubes? You know, what testing happens on these to make sure that they're strong and so on and so forth?
Right, well, it was actually the first tube to pass the agreement test, which is the hailstone test.
And we've had a lot of those recently.
That's right. Well, we did independently, without us actually knowing as a company. There was a guy in Ireland that actually did an impact test. Now, I don't know if you guys know hurling.
Yeah.
In England, it's cricket with a funny shaped bat. But sorry for the Irish. But basically, what he did, he actually got a hurling ball and hit the hurling ball flat out at the tubes, and it actually bounced off. Now, that's actually
hit
on
him
YouTube.
in the head, knocked him out. No,
he actually just missed his car, which would have been funny if it did it, I must say. But we didn't actually know he'd done that. So when they actually did it, he actually hit the hurling ball, which is like a softball, like a cricket ball.
It's still pretty hard, though.
Yeah, for sure. And he hit it 3 times at it, and it just bounced off. So for a impact test, I think it's a really good way.
Now, look, the guys are screwing those, or putting those, not screwing them in, but inserting them now. Do they start to heat up immediately?
They will, yes. I mean...
But are they all right to handle, though?
Yes. The good thing about this is our evacuated tubes is we've got no air in the tubes whatsoever. There's different types, which is a Sydney tube, which is basically like the thermos flask. Well, what we do is we actually drag out all the air out of the tube itself.
Right.
So there's nothing in there. So in reality, the glass will stay cold, but the limiter at the top and the manifold will get very, very hot.
And so you don't need all the tubes in for it to start working. They'll all start working independently as you insert them.
That's right, yes. I mean, we also do say as well, if you're not going to be using the system, if it is a new build, then we always say turn the tubes around.
Right.
Because obviously you can see the absorber is a flat absorber blade inside.
And clearly it won't start to work properly until you fill and flush the system,
That's
which we're
right.
going to look at in a moment.
That's right.
Yeah, in terms of where you can put these on the roof and the sort of roof you need, again, is there an issue about the pitch of the roof and where it's facing? Can it work on all sizes, all types? All shapes?
Basically what we do is with the heat pipe, we have to install them between 20 and 70 degrees because obviously, as you know, heat rises. So it actually rises up in the tube to the limiter at the top and then transfers the heat in the dry pocket at the top. Now, as a company, we also do the direct flow system. So we could actually fit those between 90 and 0 degrees.
Right.
Because it's actually forcing through. So we have got an option for either.
Right, Steve, as I'm looking at this looks incredibly simple. Just to insert, and how secure are those in there? I was going to ask Simon, but he'll tell me they're incredibly secure, but I want to ask you as someone who installs these.
Convenient system and simple to install, as you've said, because we've got small light items to carry onto the roof and put them in one at a time. Now, these clamps are simple. These little guides, all they're doing is holding the tube laterally. Once we finish putting the last tubes in, the manifold cover comes down and that clamps them all securely at the top.
So what's the performance like compared to flat plate?
Well, I mean, we like to say about 30% more efficient than a flat plate collector, but obviously I can't say that.
You just did?
Well, okay. I say that.
Yeah.
No, we're looking about 30% more efficient because obviously on a flat plate you've actually got air inside the collector itself, whereas we haven't, so we've got no thermal losses in the tube at all. So whatever light and heat we gather, we actually use. Whereas on the flat plates, you get a lot of reflection, and obviously you'll get the thermal losses.
Right. Steve, I think we're fine. You can put that last one in. We don't have to go all the way. Stick that in as well.
Thank you.
That's all right. I can see you building up a good old sweat up there. It's a hot old day, isn't it? Now, I know that Plumstead have got some competitive offers on the solar thermal packs, haven't they, at the moment, in particular. I know that if you're an installer and you want to be trained, you need to be Easy MCS accredited. Adam over here, Easy MCS, he's the man to talk to who can help you out. And there's, again, special offers on training taking place as well. What for you is the best feature as an installer of these things, as far as you're concerned?
Of this particular system?
Yeah.
It's the ease with which we can get it on the roof, because you can carry each item, one person, pass it up or climb up ladder with it safely.
Brilliant, brilliant. Now, renewable heat incentive, just talk to us a little bit about that. I mean, I'm going to do a bit of a demonstration in a moment and go through it, but there is certainly an incentive here, isn't there?
Yeah, for sure. Solar thermal is probably one of the cheapest renewable technologies that's going to go for the RHI. And it's got a pretty good return on it as well. Now, everybody uses domestic hot water. We'll have a bath, we'll use it for washing up and things like that. Now, if we can gather it for free and get paid for every kilowatt hour that we generate, then it actually makes sense. So as for the RHI, then yes, I think it's a fantastic piece of kit for the RHI because you're getting paid per kilowatt.
Brilliant. Simon, Steve, Nick, thank you. Stay where you are. I don't trust you. I trust both of you, though. Anybody got a question they'd like to ask? Yeah, let me just get the microphone so everyone can hear the question, if that's all right.
Unless I've missed something there, the actual brackets that fit to the main structure of the roof, is that it? Can they not flap around?
No. Basically what you'll find is once the stainless strap is actually installed on, the tile will then come back down and sit on the top. And then because we've actually got the panels on and the way it's actually constructed, it doesn't flap, because if it'd be wind, a flat plate would be like a kite. But because it's tubes, it actually goes through the tubes, so you don't get that movement.
Ah, right, okay.
Plus, you don't fit them too close to the edge of the roof where you've got a higher wind load.
In fact, they have to be about a metre away from the edge of the roof, don't they?
That's right. And wind loading is something that you will do a wind loading calculation as part of your design at that stage. Now, this product's been tested and approved under those standard conditions.
And I wasn't quite sure what you said about the degrees.
Yeah.
But how about orientation?
Right, orientation, then obviously we know south facing is ideal, 90 degrees to the sun. But the thing is with our actual tubes, if we are just south, southeast, south, southwest, what we could actually do is twist the tubes. Because we've got a flat absorber plate, we can actually twist the tubes up to 20 degrees to actually gather the sun from the south. So, but the good thing about these, they actually work on light as well as heat as well.
Lovely. Thanks very much for that.
Brilliant.
Okay.
Just one final question.
Yep, fine.
Feeding domestic boilers with warm water, is that something that the system does?
Right, there's different manufacturers will do either a solar ready combi or a solar ready boiler. Because the solar is actually a secondary heat source, we'd have to have a twin coil cylinder. Right. Now what we always do, we use the solar as a preheat system into the bottom of the cylinder. And then the primary boiler will go through the coil. So you're not actually sending it through the coil, through the boiler. It's actually going through a cylinder like there. So you're preheating in the bottom. And if we can preheat up to, say, 30 degrees in winter, then that's basically cutting the gas bill in half to get it up, because it'll take about the same amount of energy to get from 6 degrees incoming to about 30 as it does from 30 to 60.
So you haven't got a system that actually would feed the boiler, so for the central heating part of the system, so you're assisting...
Solar thermal is not designed for central heating. It's only designed
as an assist? No.
Yeah, it's only designed as for domestic hot water, because usually with the heating, solar thermal works best in summer and obviously when it's nice warm days. Usually you not have your heating on.
Right, okay.
So
yeah.
There is ways of doing it.
We'll have a chat afterwards.
Yeah, yeah, we'll have a chat.
I think you found a new friend here, actually, so I have a chat. Does anybody else like to ask a question? By the way, oh gosh, we've got whole hands going up here.
Whoa.
Any information you may want, then see our guys with the blue ties and the blue scarves. They'll scan your badges and they'll get some more information. Yes, sir.
Steve, I think you were going to say something about
just hold it a bit that way.
About weatherproofing the pipe entries into the roof.
Thank you, yes. We've fitted the panel, the array of tubes here. Now, obviously, what we've got to do next is connect it. It's going to have solar fluid going through this, which is a glycol-based antifreeze, because obviously in winter it's going to be sat on the roof outside, and the correct mixture will protect that down to minus 20 odd degrees, minus 28 degrees or so. So at the end of this system here, we will make hydraulic connections at the end of the manifold. And we have some special fittings here for this. I'm not going to fit them on because they're a devil to get off again. But these will connect onto some solar pipe which goes through into the roof. Now, what I said earlier about maintaining the structural integrity of the roof is just as important here. And so we have some proprietary products. This is a flashing made by Dex, and this can be used. We'd remove a tile, put this in instead of it, and make the penetration through this latex seal. That's how we get the pipe into the house without letting the rain in as well.
And interestingly, you did a subliminal advert there, but you're saying putting the pipe onto the fixing it on, it's very difficult to take it off. So clearly, it's an integral part and important and works really well.
Yeah. We actually do a first fix kit as well. So if the roofer's putting the panel on, they could actually put the. We give a metre length of pipe which you can actually put through to the roof, ready for the plumber then to do the wet circuit down to the
Brilliant.
coil.
We've got a couple more questions. This gentleman, then yourself. Okay.
Actually, the question that I wanted to ask you is about what the gentleman mentioned about the orientation of this.
Yeah.
I'm trying to really compare the flexibility and the rigid aspect of the panel and the tube ones that you did mention, like something to do with the changes in temperature. That if the temperature, if you're not receiving maybe enough heat, probably due to the sunlight, then you can easily go over there to the tube and change the direction of the tube to actually receive the direct sunlight. Is that what you mean?
Yeah, that's right. If we are south, for example, the sun comes up in the east and goes down in the west, as we know. Now, south facing is ideal because we can gather the irradiance all the way over. Now, what we can do is if the roof is just slightly off, we can actually twist the tubes up to 20 degrees. So that way, we can actually, if we're facing that way, in reality, the tubes are actually facing that way. Do you follow me? Because we actually twisted the tubes.
Yeah, I understand. That's what I'm saying. So, in which case, you cannot do that to the panel.
No, not the flat place. No, that's right. We could also do east-west as well, which is not a we could do one on the east, one on the west, and gather the radiance as it comes over.
Okay.
But I think we can have a chat afterwards about that.
Thank you very
Someone told me
much.
north facing is actually better than south facing. I don't know. Yes, sir.
Thank you. A similar question, very quick question. A south-southeast facing roof, but it goes into shade in the winter from about 1 o'clock, 2 o'clock in the afternoon. So one wonders, is it worth doing solar thermal if your roof goes into shade for a 2 or 3 hour period in the end of the day?
Short answer is yes.
Yeah.
Solar thermal obviously is going to be affected by shade, but it's not as much as PV systems have traditionally been affected. There's no electrical consequence. Now, as part of the design process, the MCS installer will assess the level of shading from your roof and will give you a predicted generation of heat based on that location, orientation, and shading.
Okay.
So before you were asked to go ahead with the solar thermal installation, provided that you're using an MCS accredited installer, then they will have given you enough information to make that judgment.
Okay, thank you.